morning, students. So far we have discussed in the chapter of laws of motion about Newton's first law and Newton's second law. We found that in Newton's first law, if there is no any external unbalanced force, an object stays at rest. If it is at rest, an object continues its uniform motion if it is in motion. And in the Newton's second law, we found that the rate of change of momentum is directly proportional to its applied unbalanced force, and it takes place in the directions of the force, which direction force acts. So today we're going to discuss about Newton's third law of motion. Newton's third law of motion. Newton's third law of motion. So what is Newton's third law of motions? We'll discuss today. Now before going to discuss Newton's third law of motion, let us take some example of it. You see, when we walk in the floor, when you walk on the floor, then when I am walking on the floor, I am giving some pressure or I am giving some force to the floor. At the same time, the force is also exerting some force on me. Are you getting the point? Once you are walking on the road or once you are walking on the floor, your body is giving some amount of force on the floor. At the same time, the force is also exerting some amount of force to you, hence you are moving forward. That means if you consider that this is a road or this is the floor, and this is the man who are walking. Here he is walking like that. That means once he is walking, he is giving some force on the road, hence the road is also giving some force as a reaction to that particular person, hence he is able to walk ahead. Similarly, once you are swimming in the river, then what happened? That you are just swimming in the water, means you are what? You are throwing your hand, you are putting pressure on the water or not. That means once you are swimming in the water, that means what? I'm moving forward. How? Just I am giving some pressure to the water like that. Once I am removing the water in front of me, that means I am giving force on the water. Hence, water is also giving some force to me so that I can go ahead. And the same thing again happen that in case of the best example of Newton's third law of motion is the gun. Have you seen the gun? That if I consider a gun concept, suppose this is the gun for us. Okay, suppose this is the gun for us, a recoiling of gun. This is the best example of Newton's third law of motion. That once the bullet will go away from the ground, suppose this is the bullet, that means the bullet is, this is the bullet, and bullet has been fired out from the gun. So what happened in this case? Once this bullet goes out from the gun, okay, once this bullet goes out from the gun, then if I consider this is the gun, that means I am taking this is a gun or pistol. So once I fired it, once the bullet will go out from the gun, a back force, will given to my hand also like that. Once I push the trigger, once the bullet will go, another back force will affect on my hand. That means when the bullet will go away, another opposite force will act on the hands of the person who are holding the pistol, or another opposite force will be produced or opposite force will be given to this particular pistol. Am I clear? That means the magnitude of this force will be same. Magnitude of the force will be same and direction will be opposite, remember. when the bullet is fired, the speed bullet will go away from the pistol. At the same speed, another force will be exerted towards the opposite direction. This is reaction force. Okay, this is your reaction force, and this force will give a thrust to the person who are holding the pistol or who are holding the fire. And in case of bigger rifle, or in case of like AK-47 or something like that, then where you hold this bonduk like that, once you hold this AK-47 bonduk like that or rifle like that, then what will, once I fire these things, when the bullet will go away, a back force will hit the persons. What? This is the reaction. As the bullet will go, the bonduk or the gun will hit your chest or hit your arm. So this is the reaction force. Interestingly, the magnitude of this force will be same. Okay, if I consider this is the force that is going FA and this is FB, this is the force by which the bullet is going out, and this is the force when an opposite force is given to a pistol. So in this case, the magnitude FA is equal to FB, but the direction will be opposite. Am I clear? The direction will be opposite. But questions comes, if the magnitude is equal, why the bullet goes a long distances and your pistol goes for lesser distances? Because the bullet which is going out from the pistol, that is less in mass of the bullet is less, and the mass of the pistol is more. That is why the pistol does not travels more distances and a bullet travels more distances. Is that clear? Similar case we can also find in case of our sun and the earth. Okay, or suppose if you consider, suppose this is your moon. If I consider this is the moon and this is the earth. Okay, this is the moon and this is earth. Okay, this is moon, this is earth. But here also the same case happens. The amount of force exerted by the moon, suppose Fm, and amount of force exerted by earth is Fe. You don't think that in this case the force exerted by earth is greater than force exerted by moon? No. Force exerted by earth is equal to the amount of force exerted by the moon. Magnitude are same, directions are opposite, that's true. But again question come that why this moon only moves around the earth, not the earth moves around the sun? So it's very simple, because earth has got more mass, hence the inertia of earth is more maximum, and the mass of the moon is very less in comparison to earth, and inertia of moon is less. That's why the earth moves around the earth and earth does not move around the sun. That's the thing you remember. But amount of force exerted by each other is equal. That means, as you can say here, Fe is equal to Fa, maybe opposite. Okay, directions of the force is opposite, but their magnitude are same. Am I clear? So in this case, by watching this examples, we can see, we can have an idea about Newton's third law of motion. Again, the launching of rocket. Everybody have seen the launching of rocket, by which process the rocket launches. If I consider a rocket, suppose in front of you, that or a launching of a spacecraft, all these things, that is, suppose it is a rocket, I am considering to be. So what happens when rocket launches? What happens? There is some exposure is burned in the backward. That means when these exposures were burned, an opposite force is given like this way. That means a tremendous amount of force is exerted. so that rocket can lift upward. Am I clear? That these explosions of the gases will give a force in this way, hence it will give a opposite upward thrust or upward force. So these are the examples of Newton's third law of motion. That means we can say, by watching all these experiments, we can say what is Newton's third law, that it is a very famous one. Every action has an equal and opposite reaction. Okay, so this is the famous one, Newton's third law, that every action has an equal and opposite reaction. I have given some example in front of you, and that means example of recoiling of gun. This process, this process is called recoiling of gun. When we fire it, and the bullet goes away from the gun, and hence the gun give a back force on the hand of the holder. This is called recoiling of gun. Am I clear? Launching of rocket, and then I have told you again what the forces exerted between the attraction force between earth and the sun, attraction force between moon and the earth, all this thing. So these are the some example of when we are climbing on the, when we are swimming on the river, and when we are walking on the road, when we are walking on the floor. So these are also some effect of Newton's example of Newton's third law of motion. Okay, so you can write a question, then about you can write some example of Newton's third law of motion. So as you can write that recoiling of example, as for example what, recoiling of gun, recoiling of gun. Okay, recoiling of gun. Then you can say launching of rocket, launching of rocket, launching of rocket. Again, finally we can go for like what as you can see that what, walking on the floor or walking on a road. Am I clear? Swimming in the what, river, swimming in the river. Okay, so these are some examples of Newton's third law of motions. That is a very simple topic. I hope you have understood it. For today, thank you so much.